Alright, welcome back guys. If you need any problems solved, just reach out. Even if it's a different textbook, we're doing section 3.4, question 21. So first step, figure out what the problem is asking for. It wants you to practice polynomial rules. It wants you to notice that there's a multiplication here, which means you're going to need the power rule. And finally, there's brackets here, which probably is a good sign you're going to use the chain rule. You guys should drill into your head that if you see brackets and there's x's inside with something being done on the outside, it's going to be a chain rule. So let's go over the derivatives we need. This is a standard polynomial derivative rule that you probably have seen a billion times now, but there's actually a hidden little chain rule in here, which is technically we should be multiplying by the derivative of that x, but the derivative of x is just 1, and multiplying by 1 doesn't change anything. So with x squared, if you did the full chain rule here, you get the same result. Same thing with x to the power 1. Technically, you should be using the chain rule and applying by this x. The difference though is that if you have something inside that's a little bit more complicated than x, it might not always derive to something so simple as 1. Okay, now we get to jump in. So we generally start with the product rule first, and then we do the chain rule. So the product rule is basically take the derivative of the first part, and I put extra brackets around that d over dx to imply the derivative operator only applies to the first term, with the rest left alone, plus the first term left alone, and the derivative of the second part taken. Alright, so I'm going to apply the chain rule to 1/2 at a time, only because I have a limited amount of screen space. If you had a really big page, you could just make one really big line. So for the first half, what I'm doing is I'm taking the old power, which was the 3, I'm moving in front, and then I'm subtracting 1 from the old power in the exponent. And then I'm multiplying it by the derivative of the stuff on the inside. The stuff on the inside, though, is not going to become just 1 like it did before, because it's a little bit more complex what's on the inside. And then I'm just multiplying by the other stuff still left alone. So the derivative of 4x plus 5 is just 4. So I've replaced that derivative operator with 4. And of course I've done the step in the exponent of 3 minus 1 is equal to 2. And now I've simplified it a little bit because we have a 3 and a 4 being multiplied by each other, and 3 times 4 is 12. So I just move it in front. Now doing the second half here, we have 4x plus 5 all raised to the power 3. Nothing's really happening with this part because the first part gets left alone, and we're only applying this derivative operator to the second half. So that 4 comes in front, and I reduce the power of the 4 in the exponent by 1, and then I multiply by the derivative of this stuff on the inside. So in the next step, I'm going to take that derivative, and basically the derivative of x squared, well, that's 2x. And then I'm subtracting 2x, and the derivative of minus 2x is just minus 2. So that's why that last term at the end becomes 2x minus 2. And then in the exponent, I've just done the step of 4 minus 1 is equal to 3. And now the next thing that I'm going to do is I'm just going to rearrange stuff so it looks a bit nicer. And I'm putting stuff of lower power in the front that looks a little bit less complicated, and I move the 4 to the front. That's pretty much it. And so putting the two halves together, we just end up with our answer from the first half plus our answer to the second half, and that's it, the problem is solved. So the main areas where you could mess up here is reducing the power before putting it in front and messing up on that order of operations. Other than that, it's a pretty simple, straightforward problem. Yeah, if you guys need any more help or you've got more questions and you'd like help on a problem, feel free to reach out. Even if it's a different textbook, you can just let me know what textbook and chapter in question. I can probably find it. And yeah, hopefully you guys found this helpful. There should be a playlist with some more videos on that side over there somewhere. Have a great day, guys. Take care.